All right, so we've created the instance variables. We've created the default constructor. We've created the overloaded constructor. We've created getters. We've created setters. We've talked about access modifiers. The last thing to really talk about, well, there's a number of things to talk about, but I should say the next thing to talk about is overriding of several methods. Okay, so in the next lesson, we're really going to get deep into the concept of inheritance. Okay, so I don't want to jump into that too early, but there are two particular methods that already exist. And what I will say is anytime I create an object, a new class, this class inherits from what is called the object class. And the object class has a number of methods that already exist. Okay. Again, don't feel bad if you don't quite fully understand what I'm saying. I don't intend you to understand exactly what I'm saying yet. But what I do want you to know is, again, let's go back to the example where I said in an earlier video, if you pick up a pen, you could say also that that pen is an object, right? If I pick up my computer mouse, I could say that that mouse is an object. Okay, all objects have some kind of property, right? Like a weight to it, for instance. A pen has a weight, but a pen has some very specific properties that not all objects have, right? All objects have a weight to them. So that similar concept exists in Java as well. Anytime I create a human or a new class of any sort, it is also considered to be an object. And that object has some kind of methods that we kind of get for free. So for instance, if I type in Dr. Dan dot, you'll see all the humanoid things that I created. So you can see over here in this kind of grayish text over here, you see humanoid next to get defense. All right, I created that method. Same next to get homeworld. I created that method. Get name. I created that method in the humanoid class. But then you'll see all this other weird stuff. The object. You see a bunch of object methods, so to speak, that maybe you didn't write. Right? You have no clue what they are. So there's two of those which are almost always useful to do what's called overriding. Okay, so let's say, for instance, that I'm going to come down here and I'm going to say system.out.print. Okay, print line. And I just pass in Dr. Dan. And the question is, what's going to happen? What's going to happen when I just try to print out Dr. Dan? Okay, and we see something very interesting. It says humanoid at some bunch of numbers and letters. Okay, if you recall from an earlier, I think when we were working with array lists, this is the address. It basically tells you the class type. Hey, this thing is a humanoid, which is marginally useful. And then it tells me where in my actual physical memory, so to speak, or at least virtual memory, where this humanoid data actually sits. Okay. Now, what did I want to happen? Right? What did I want to happen? And the question, that's kind of an open question, right? When I just tried to print out Dr. Dan, what did I want to happen? Well, probably to print out some information about Dr. Dan, right? If I asked you to tell me about your car in your garage, well, you'd probably say, oh, yeah, I got that red Mustang and it has a V8 in it or whatever. So typically when I want to print out an object, what I want to do is print out the properties of that object. Okay, so for that reason, every object has a toString method. If I do toString, okay, what we'll see is it's actually going to do the same exact thing. Okay, if I call toString or without, basically if I just try to print out Dr. Dan, it's going to actually call that toString method. I'll leave it there for now just to kind of be very explicit about what we're doing. But if I hover over, I'll essentially see that there's this method. It's from the object class. Again, if I do the dot and start to type out toString, you'll see, yeah, that method belongs to the object class. And that method, put my dot back, that method has a function prototype of, I don't know if it shows the whole thing in here, but it returns a string and it takes in no parameters. Okay. So what we can do in our humanoid class is it's up to us, since we defined what this humanoid was in the first place, what are the different instance variables and properties that make up a human. It's really up to us how we decide to print it out. Okay, and I can basically write that way. I don't have to come up here and kind of write, okay, well, if I want to print out Dr. Dan, then print out Dr. Dan dot get name, and then Dr. Dan dot get attack, and all this different stuff, right? That would really just be describing me. I don't really want to type that out, especially if I wanted to do that for generic person, right? Then I would say generic person dot get name plus generic person dot attack and all those different things. I really just want to say to print out Dr. Dan or Dr. Dan dot toString. Okay, so how I can do that is I can come and actually overwrite or override the toString method. And in order to do that, I have to use the exact same prototype as is found in the object. And the prototype, again, is that access modifier, the return type, the method name, and the specific parameters. So in this case, it's going to be public string toString open close parentheses, okay, like that. And I may, let's see, we're missing a return statement. I don't know why it wants to return attack. Let's just go ahead and I'll do an empty string. Okay, so what's going to happen, you'll see now when I play this, it literally doesn't do anything. It just puts an empty line there, right? If I said, hey, something, and then I printed this out, you'll see that, hey, something gets printed when I tried to print out Dr. Dan dot toString. I'm going to go ahead and copy this line, and this time I'm going to copy and paste generic person over top Dr. Dan. So and you can start to hopefully see the power of where we're going. When I play this, right, for both generic person and Dr. Dan, I'm just getting, hey, something. Okay? So what I can do is in this humanoid, I could do something a little bit better than that by just saying name. And that would be like infinitely better. Right? So now when I play this, you'll see I'm getting no name and Dan, because those are the two specific names of those people. All right, so in the toString, it's really up to you how you want to do this. I typically write programs that are very kind of user human friendly to read. So I tend to kind of write out these toString statements as sentences. So what I'm going to do is I'm actually going to create a string, and I'll just call it return, like RET for return, and then I'm going to return it. So I'll say return RET. Okay, now it's giving me an error because there's nothing there. But what I'm going to do is I'm going to say, well, this is equal to string dot format, and then I'm going to have some kind of formatted string in it. Okay, so what I want to do is I want to do something where if I do my open close parentheses, I want to do something like the name. Okay, so I'll do like the name %s, and then I will put a comma there, from some homeworld, right, %s, %s, no, then I'll just say like has an attack of %s and defense of %s, period. Okay, so now I just need to replace all these %s's with the particular information, right? So that first one is the name, the second one is the homeworld, the third one is the attack, and the fourth one is the defense. Okay, so now what's really cool is when I run this, you'll see that for free I basically get, right when I call that .toString, I get no name from Earth has an attack of arm swing and defensive cry. Dan from planet Earth has an attack of keyboard smackdown and defense of keyboard shield. Okay, so overriding that toString is as simple as that. And then you can see I can actually delete the toString because it's kind of implicit, and it's going to call that same code. Okay, so you can see very clearly whether I have that toString or not. If I just try to print the object itself, it's basically going to try to print it by calling the toString method. Okay, so that is that's the toString method. Okay, so now what I want to take a look at is the equals method. Okay, how the equals method works. We should be familiar with the equals method using the string. That's where we've basically seen it. Okay, so I'll create string s equals, and and I'll just type, let's just say Dan. You can type whatever you want there. And then I'll say string S2, okay, maybe I'll call this first one S1, equals Dan as well. Okay. Now, earlier before, we had talked about the dot equals method. Okay, so let me actually write out a few lines here to kind of demonstrate a concept here. I'm going to say system.out.println, okay, and I'll say S1 equals S2. Okay, and I'm going to say that, I'll just kind of draw some arrows, a fake arrow to basically say that evaluates to S1 equals S2, and this should print out either a true or a false. Okay, if I run this, what you'll see is it basically says, hey, does S1 equal S2? And it says true. Okay, that was actually a little bit surprising. I think I just learned something new about Java. I can demonstrate this in another way. Let me build this up just a second. But now this next one, I'm going to say I don't know if I had that there when I paused the video. I kind of went to research this for a second real quick. I'm going to do a system.out.println, and then the next thing I'm going to compare is S1.equals S2. Okay, so we use this in earlier modules to compare two strings together. We said, hey, if I want to really see if the two strings have similar content, then I need to do it using this dot equals. Okay, so here when we concatenate S1 dot equals, I don't know why it always does that, S2. Okay, now when I play this, I actually get true and true, which, to be quite honest to you, was not what I was expecting. And what I want to show you is that there's another way that I can actually define strings. Okay, we've always done it using this kind of just equals and then given it a literal. I can also say new string and then in parentheses pass in that literal. Okay, so you'll see here. Okay, so before when I ran this, right, I was getting true and then false. Now when I run it, you'll see I get false and true. Sorry, I think it was true and true before. I think you probably saw it right that it was true and true, but I for some reason added a false in there. So what we're seeing, and this is actually what I was basically expecting, and this is the general rule. When we had a string, we always did dot equals because dot equals would actually compare the content. It would actually look at the D and then the A and the N. So if I change this to a capital D, for instance, we would get false for S1 dot equals S2. There was also the dot equals ignore case where, right, we could ignore the case and then this indeed would get us true, right, if we say dot equals ignore case. Right, so now we get true for that, even though Dan and Dan are two different things. Probably would be we'll leave it like that. So anyway, the point that I want to make here is the equals is basically saying, is S1 and S2, are they two physically different objects in the real world? The dot equals is basically saying, do these two objects have the same properties? Okay, so let's go back to my garage example. Okay, I have my two-car garage, and let's say I have that red Mustang in my garage. Okay, and I've got that red Mustang, and my wife loves that car so much that she goes out and buys one for herself. Okay, and so she pulls into the garage, and wow, we have two red Mustangs in our garage. Exact same car. Okay, but is it? Okay, is it the exact same car? Okay, so if I use that terminology and said, wow, my wife bought the exact same car as me, what I'm talking about is I'm saying dot equals. Okay, I'm saying dot equals. I'm basically saying, hey, the properties of her car are exactly the same as the properties of my car. right? They're both Fords, they're both Mustangs, they're both 2021 models, they're both convertibles, they're both V8, you know, whatever, however many liters. They're literally the exact same properties. They're dot equals. But do they equals one another? If I said that, then the answer would be no. Okay, are they? You know, if I go and take my car out for a spin, her car is still available right there, right? Because they're not the same car physically. They're the same car in that they have the same properties. But if I'm talking about two physically different pieces of matter in the real world, then no, these two cars don't equal one another in that sense. So that's the difference between equals and dot equals. Equals is basically saying, hey, are these the two, like, are these physically the same things in my memory? Like, are they taking up the same physical space in memory? And dot equals is saying, hey, I don't care if they take up the same physical space or not. What I'm really wondering is, do they have the same properties as one another? Okay, so you always want to have some kind of notion of the dot equals. Okay, so now that I've created this humanoid, I really have no clue whether, you know, these two items are of the same properties. Okay, so for instance, if I wanted to know, let's do another line up here. We can say system.out.print line, and I could say something like generic person 1 equals generic person 2. Okay, I'm going to do the same code up here. I'll say generic person 1 equals generic person 2. Okay, and then I'll go ahead up here on my generic person. I'm going to rename this, so I'll do an Alt-Shift-R, and I'll just add a 1 at the end there. So now I have generic person 1 everywhere. I can hit continue. And then I'm going to go ahead and copy this line, and now I'm going to create a generic person 2. Okay. So I got an error right here, and why do I have an error? Remove argument to match print line boolean. Oh, sorry, I need a plus symbol right there. And then maybe parentheses. Yeah, there we go. Okay, so I'm going to copy this line. I'm going to paste it. This time I'm going to say generic person 1 dot equals. Okay, and I'll go ahead and do my update this code. So generic person 1 dot equals. Perfect. Okay, so when I run this, what you'll see is that they're actually both false, right? In some sense, you expect the first one to be false because I've got these two generic people and they're totally different, right? Because if I actually printed them both out, let's go ahead and we'll beef this up a little bit. We'll say generic person 1 Okay, so we'll do that line, and then we'll do the same thing for generic person 2. So just copy and paste that line. Okay, I'm gonna get rid of this Dr. Dan for now, this print statement. Just move it up. Okay, so if I play this, right, and then I'm actually just gonna go ahead and redo this whole thing. I'm gonna copy and paste these 4 lines. If in the middle of this I should come and I should say generic person 1 dot set name, and I said something else like Johnny. When we run this, right, so we get, hey, no name, no name. These are both false. Equals is false, and dot equals is false. So this is saying this generic person 1 equals generic person 2 is false. That's basically saying, hey, these are two physically different people. And we know that, right, because when we actually run this line of code to change these, we see that in fact one is now different, right? But the dot equals should be true, right? Because when I create generic person 1 and 2, they should both, right? They both have the exact same toString statements, right? Which means they have the exact same properties. So I need to override what this dot equals method means, right? I just created a new humanoid, and basically there's no sense of understanding of what it means to be dot equals for one method to be dot equals the other. All right, so that's kind of the equals equals and the dot equals and what those are all about. So with that, it's up to me to define that. Okay, if I look at this dot equals, you'll see that this was a method from the object class. It returns a Boolean and it takes in an object. Okay, an object is just any object. It could be a human, it could be a car, it could be a robot, a droid, whatever. Okay, so I'm going to go ahead and I need to make sure I get that exact function prototype. So I'll say public Boolean equals, and I'll take an object, and I'll just take in some object called O. Okay. So now it's up to me to return some value. And I'm basically going to do a few things in this equals method, okay? The first thing I'm going to do is I'm going to check, I'm going to say if object O is not a humanoid, then not equal. Okay, so the idea is I could actually up here, right, I was playing kind of nice. And when I said, hey, generic person 1 dot equals generic person 2, I was passing in another humanoid, right, to see if those two had the same properties. But I don't have to do that. I could pass in some string, right, because what we saw just a little while ago was that, right, a string is an object. I create it using the new keyword, so it's an object, right? Now it's kind of giving me some kind of weird, I've actually never seen this before. It's a green warning, unlikely argument type for equals. String seems to be unrelated to humanoid. So that's kind of a nice warning that kind of gives me a hint that I'm probably doing something a little bit unconventional. But the point is, right, I could run this code and it would run just fine. So the first thing I want to do is basically check. I'll go ahead and undo this. I'll bring my generic person 2 back in there. Okay, so if object O is not a humanoid. Okay, so what I'm going to do here is I'm going to write a simple line of code. It says if O, this is a new keyword I don't believe we've looked at yet, instance of humanoid. Okay, so again, a pencil is an object, a pen is an object, a humanoid is an object, a mouse is an object. That makes sense in English, right? Those everything we could hold is an object. Okay, so basically saying, hey, I don't have any clue what I am a humanoid, right? Because I'm in this humanoid code, but I don't have any clue what you're going to try to compare me to. So if what you try to compare me to is not even a humanoid, then I just return false. I say, hey, we do not equal. So what I actually have to do is I need to put a not sign, and I'm going to surround this O instance of humanoid. Okay, this statement right here, this O instance of humanoid, is a Boolean expression. I need one more parenthesis there. This whole thing is going to return true or false, right? So if I pass in that string, is that string an instance of a humanoid? No, right? If I pass in that generic humanoid, right, or generic person 2, then generic person 2, is that a humanoid? Yes. So that will be a true statement, but then I just invert it. Okay, so what I'm saying is, if O is not an instance of humanoid, then I return false. I know that it's a false statement to say that they equal one another. Okay? However, if I make it this far, then I know that I do have a humanoid, right? So we do have a humanoid. So if then the next thing I'm going to do is I'm going to say if this object has properties that do not match with the other humanoid's properties, then not equal. All right, so at this point I know I have a humanoid, so what I'm going to do is I'm going to convert that object to a humanoid. So I'll say humanoid, and I'll just say like other humanoid equals, and I can basically say O, I'm basically saying, hey, that O is really a humanoid, but I have to do what's called casting. So I'll just do the quick fix and it'll add it for me. So that's basically my way of saying, hey, at this point in my code, I know that this object, it's not a string, it's not a pen, it's not a water bottle, it's a humanoid, right? Because it passed this test right here. So I cast it, and what that allows me to do is it allows me to get access to all the humanoid properties and methods, right? Because if I just said O dot, it's only going to give me the object methods. I can see, for instance, toString and equals, all right? But when I cast it to a other humanoid, that allows me to say things like other humanoid dot attack, defense, home world, and so on and so forth. Okay, so what I can do now is I can say if not name dot equals other humanoid dot name. Okay, and then let me have my parenthesis there. Return false. Okay, so essentially what I'm saying is, hey, I pass in this other humanoid. If my name does not equal that other humanoid's name, then return false. We're not the same. We don't have the same properties, right? We're not the same in that sense. So what I'm going to do is I'm actually going to do the same logic for every single instance variable, right? I'm just going to basically say, hey, for me, what it means to be dot equals, for me, what it means to basically say, hey, we're like the same. We're like, you know, we're those two red Mustangs in the garage. We're not physically the same objects, but for all practical purposes, we're the same car, right, in properties. So I'll go ahead and just copy that, and I'm going to put an OR statement in between each time I paste it. Okay, and then what I'm going to do is I'm just going to replace, right? So instead of name, I'm going to check home world. So I'll replace the second name, second and third name, right? Or these, the second equals with the home world. And then the third little equals I'm going to change to attack. And then the fourth one I'm going to change to defense. Okay. So now what I'm saying is if my name does not equal the other human's name, or my home world does not equal the other human's world, or my attack does not equal, basically if anything is different from me versus you, I'm going to say false. Okay. Otherwise, if we made it this far, this humanoid's properties all match the other humanoid's properties, so they are equal. Okay, so then I return not false, but true. Okay, so I return true. So now when I run this, we're actually going to see that generic person1 equals generic person2 is false, but generic person1 dot equals is true, right? Then I go ahead and I change the name, so you can see now they're not the same in name, and this generic person1 dot equals evaluates to false this time because their properties are in fact different. Okay, so I could go ahead and annotate this a little bit just for readability's sake. So we can basically say after name change, okay, and then I'll say before name change. Okay, and then I'll go ahead and I'll put a tab in front of each of these. So hopefully this prints out a little bit nicer, right? Before name change, and then after name change. And if we want, you can rename these variables, right? So this is just a mouthful to actually read. So if I wanted, I could Alt-Shift-R this to GP1, and then Alt-Shift-R the second one to GP2, generic person 1 and 2. And then of course in my print statements, if I want, the easiest way to handle this is just to highlight it and then do a Control F. And then on the replace with, you can do GP1 and just replace all. And then same thing for generic person 2. I can just go ahead and change this right here. It's a 2 on both places, and then a replace all. So now I think my code's a little bit more readable. It's just kind of more concise. Okay, so that was the equals equals versus dot equals, and basically showing you how we can actually program our dot equals to determine what it means for a humanoid to be the same. Now it is worth noting that, again, this is completely up to me to determine what it means for two humanoids to be equal. Okay? For instance, I could just as easily chop off the attack and defense from this. So basically if I did that, what I would be saying is, hey, if I want to know if two humans are equal to one another in the sense that they're basically the same, not the same physical matter, but hey, they're pretty much the same person, the dot equals style. In this case, I'm saying, hey, if they have the same home, if they have the same name in the same home world, then they are actually more or less the same person. So again, it's completely up to you, the code creator, to decide what it means to be dot equals from one another. Okay, so that was overriding. I talked a little bit about objects and overriding the toString and the equals method with a lot of background about dot equals and equals equals. So we'll see you in the next lesson where we start to actually create some custom methods, and we'll go from there.